What's good, YouTube? Back at it again with another video. I'm Bruce from Jump Mathematics. This is the second of two videos on how to differentiate an exponential function. What we did in the last video was we proved what's up here in the blue box, that the derivative of an exponential function is the exponential function itself times the natural log of the base of the exponential function, a to the x natural log a. So what we're going to do in this video is we're going to fill in a for a couple easy examples and then some more tricky examples, and we're going to combine that with the rule that we used last time on how to differentiate a power function. So let's get started. So in this case, we're trying to take the derivative of 2 to the x. So in this case, a equals 2. So the derivative of 2 to the x should be 2 to the x. Again, it's the same function, you just write it down, multiplied by the natural log of a, which is 2. That's it. Easy. The derivative of 3 to the x is the same thing, except in this case a equals 3. So the derivative of 3 to the x is 3 to the x natural log 3. This is my favorite one. The derivative of e to the x, a equals e. So in this case it should be e to the x natural log e. The natural log of e asks, what number do I have to raise e to in order to get e? Well, that's just 1. The natural log of e is just 1. So the derivative of e to the x is e to the x. So there's only two functions with this property, that the derivative of e to the x, or that the derivative of the function is the function itself. There's obviously d by dx, e to the x is e to the x. We just saw that. And d by dx, 0 is also 0. No other functions have that property, that the function itself is its own derivative. So here, this pi to the x looks a little bit more tricky than 2 to the x, but in this case we just have a equals pi. So the derivative of this piece right here is pi to the x times natural log pi, plus we have the derivative of a sum, so the answer to that derivative should be the sum of the derivatives. So we differentiated this piece, now we differentiate this piece. Using this, the derivative of 5x is just going to be 5, plus the derivative of 10 is 0, so I won't write that down. Now we get into another tricky example. The derivative of 5 times 5 to the t is 5 times, this is just a constant multiple, so we write it down. The derivative of 5 to the t, according to this, we have a equals 5, so we should have 5 to the t natural log 5 plus, okay, this one is a bit more tricky because our rule up here in the blue box says that the derivative of a to the x is this, but right here we have e to the t, which of course is the same as a to the x, except we have t plus 5. We don't know how to deal with that, but what we do know is how to do algebra. So let's rewrite this guy in the box as e to the 5 times e to the t. If we write it as e to the 5 times e to the t, this right here is just a constant multiple, so we can write it down just like we did with this 5. Then the derivative of e to the t, as we saw over here, the derivative of e to the t is just e to the t itself. Thank you for watching, and check out my other videos. Hey, what's going on, guys? Thank you for watching the video. If you're interested in getting better at math by getting all kinds of practice, what I want you to do is go to jumpmathematics.com. Here I provide you with free instructional videos and hundreds of practice problems. This is the best way to get better at math, by doing practice problems. See you in the next video.